So this question here is really leaning on the cofunction identity. So let me show you what I mean here. They tell you that the length of AB is equal to the length of BC, which means they're congruent, and they want the value of the difference between sine from angle CBD, and the important angle is always that middle one because that's the vertex. But notice CBD is this angle here. I'm going to go ahead and call it angle 1 just to make it a little bit easier to see. And cosine of angle BAC, which ends up being this angle right here, which I'm going to label as angle 2. So we want to find the difference between those. Now, let's go ahead and notice that if this is a right angle, this is as well because they form a linear pair, so they add up to 180. The other thing is, we know, as we could see on the back side of page 34, which is side 4 of our math reference document, triangle sum theorem says all three angles in a triangle add up to 180. And we know that, right? Now the corollary to triangle sum theorem, now keep in mind a corollary is basically just a little add-on from a theorem. What the corollary to triangle sum theorem says is if it's a right triangle, in other words, let's say angle C is 90, subtract that over, and you could see that the sum of the other two acute angles is 90. In other words, they are complementary, so that these two, when they're added together, gives you 90, plus this 90 is still 180. So if this is 34, I could find this angle here by doing 90 minus 34, and notice I get 56, so I'll go ahead and label that here. And since this is isosceles, based on what they gave us here, we have something called base angles theorem. That means that these base angles here and here are congruent. So that means this is 34 as well. And if we did 90 minus 34, clearly angle 1 is that same 56 that we have right next to it. So when they're asking for the difference between the sine from this angle, notice sine, if you ever forget, we can go to our program, we'll press up to get right to trig, and this is just one of those informational programs. We see that sine is opposite over hypotenuse. Well, opposite, let's call this x, over hypotenuse, we'll call that y. So that's x over y minus, well, let's see, what's cosine from angle BAC, which we said was from this angle? Cosine is adjacent, which, remember, if these are isosceles triangles and they're clearly congruent, same exact angle measures, same exact side lengths, this is also x. And remember, cosine is adjacent over hypotenuse, that's why I did the adjacent first, over the hypotenuse. Well, look at that. Sine from one angle is the same as the cosine from its complement. And that's always the case. So when you see that they're saying what's sine from one angle versus cosine from its complement, they're going to be the same. So when you find the difference, we get 0.